We have got one heck of a sneak peek inside the V4 cabinet for Tesla's Supercharger, and what better way to look at it than by doing an autopsy with a real mortician. I don't have a mortician, what I've got is Sith from Electric Era, the VP of software over there. He knows what goes into cabinets. He can look at this and see something other than just a mess of wires. We're going to find out what's going on in there. Is it actually clever at all? Is it good? And what does it all mean? I'm Brian. Welcome to Futuraza. Sith, good to see you again. How have you been?
Yeah, great to see you. Doing great. All sorts of crazy stuff going on over here at Electric Era.
As a reminder, Electric Era is a public fast charger company that builds their own, designs their own, does all the manufacturing in-house, deploys them coast to coast. Not as much in between the coasts. We're not quite ready for a coast-to-coast drive just yet, but it's filling out nice. You're getting there, and your uptime is what as of lately?
Over 99% this quarter, and doing pushing that further and further up.
And it's because you design it all in-house. We've been over this before. There are previous videos on the channel with Sith and Quincy and all that. Great. So what we're looking at here, like I said, I need your autopsy. This is a blurry one. I've got a better one coming up in a second. Old V3 on the left, newer V4 on the right. Substantial changes, I assume, because, well, the juice that goes through it is that much higher. Is that a good summary to start with?
That is definitely a big part of it. And like we can speak to that from our experience, having also developed and in development of a dispenser of our own. But as you really push up the power, things start to get more complicated, especially if you don't change how much space you've got inside that dispenser.
Well, they did remove the big donut hole, so that gives you some room there.
Yeah, I'm sure the engineers definitely appreciated that. They said, like, do we really need that giant hole in the dispenser anymore?
It's a lot of real estate.
Mm-hmm.
So what am I looking at here? What do I see?
A lot. So the dispenser, the V4 dispenser, just like the V3 dispenser, and is common for many dispensers, including ours, does not do power conversion in the in this like actual post here itself. All of that exists somewhere else. You can find it if you go to a supercharger, if you go to any of our sites that have that are in the Nevi configuration, you'll find like the big box that's kind of making some humming noises as you charge your car. That's where all the power conversion goes on. However, there's still a lot that needs to happen right here at the dispenser, and all of that is kind of what you're looking at. So
just to clarify real quick, if I'm charging level 1 or level 2, the power conversion is done inside my car.
Yes.
And if I'm doing level 3, it is happening curbside.
Effectively, yeah. And then it's kind of up based on the technology. You can choose to put the power conversion kind of in the dispenser post itself. You could do that and run the AC, like the grid power, all the way to the post, or you could move the power conversion to some sort of like central cabinet, do it all there, and then run the power in DC to the post and then to the vehicle.
Okay.
And in general, people will move power conversion to, out of the post if they want the post to be slim and if they want it to be quiet. And generally attractive, which is one of the reasons why Tesla and also Electric Era don't put the all of that stuff in the post. It's also, I would say, a little bit safer.
If you're trying to do voltage, the conversion inside the stall, you're going to need bigger fans, which are going to be noisier than smaller, than better fan. I mean, a laptop is a lot noisier trying to cool down than a PC because you've got the space.
Practically, if somebody drives into the post, you have a whole lot less to fix if it's not all in there.
And these posts are designed to be rugged for that purpose. I've seen a few that have gotten pretty jacked up. So starting here, we've got a circuit board.
Yep.
What's that doing?
So I'll actually start kind of at the bottom of
Sure.
that box because that's kind of important. So what you see there, those two big black cables kind of running in, those are likely what we call the high voltage DC cables that are feeding in the DC power that we want to actually send to the vehicle. And so those will kind of they'll run into that box inside the dispenser there, and they terminate there. And then um, likely what you are seeing is a control board for managing that system itself. Um, and so it's probably got all of the safety logic on it. We have a similar board that does a similar function in our dispenser. It manages these things called contactors, and they're literally physical devices that will make or break a very high current electrical connection. And it's like a physical device. It just kind of either pushes or pulls those contacts apart. Um,
The
and
Frankenstein switch.
yeah, I mean I guess it's really what it's meant to do is to provide safety to the overall system, right? So if there is a problem, you make sure that those things are disconnected and it prevents any current from flowing into the vehicle or out of it, right? And so that is kind of the core of the safety system, is having that contactor there. There's a bunch of other components that are actually kind of operating under the hood inside, probably on that board, if I had to guess, because I don't see anything quite like it anywhere else in that picture.
Get a little closer. This is a much cleaner picture that we've been able to find. And here it looks a lot more sophisticated now that we can see a non-blurry version.
Yeah,
Pretty little kitty cat there. That's a thing.
Electrical engineers often will include a little bit of that that's called the silk screen on a PCB. So they often leave behind a couple of little tokens like that here and there.
Are any of these consumables on here? I know, if you look at the circuitry in an original Tesla Roadster, there were parts that have to be serviced, that have to be rejuiced periodically. Any of these? Or are these forever components?
Not. And if they were, they wouldn't be conformal coded. That's a thing that you actually see here on this PCB, is that kind of the whole thing is just lacquered effectively, right? And that actually helps protect the PCB from environmental damage. It's a very common thing that people do to PCBs, to printed circuit boards, to kind of prevent, for example, water and humidity from just slowly affecting, creeping into things, corroding them.
Do you have a problem with ocean water?
Yes, we call that salt fog. It's a kind of a standard environmental test that people have to do when producing many things, EV charging equipment among them. It's part of the training, or part of the testing program that we have to do to stuff that we are developing, is make sure that it can survive salt fog, because you don't have that problem in the middle of the Arizona desert, but if you are let's say half a mile from the coast, the Atlantic coast, that salt fog slowly gets in there over time and causes all sorts of corrosion.
Okay, so over here on the bottom left here, I'm assuming this is a drain flush for my plumbing.
This is
So
where
if
I'm
I
probably
get
gonna
hairballs,
I'm probably gonna have to get a bit more speculative here on what's
Sure.
going on the left. But one of the biggest changes that happened going from V3 to V4 is that the ampacity, the current capability, the capability of that cable to just pump out a crap ton more current, it really improved with the V4 dispenser, and as a result, the cable itself can get a lot hotter. So what we're looking at, and what we suspect, is that the majority of the dispenser volume is now actually consumed for the cooling system. And that most of what you're seeing on the left there is the heat exchanger, various aspects of the cooling system kind of running up and down that left and bottom part of the dispenser.
It definitely looks like plumbing. This coil being part of the cooling loop, I'm guessing.
Yeah, I'm actually not 100% sure what that coil does. I expect a lot of the heat exchanging it actually occurs down at the bottom where there's like that big box.
That one in the
Yeah,
corner there.
where that and then the any internal fans would also run inside there.
So that's what we're probably looking at inside this box underneath the words V4.
That's my best guess at the moment. But certainly the overall dispenser has a far higher cooling requirement than the original V3 dispenser.
Yeah.
And the V3s used to really rely a lot on they just let the cable get hot and then they would back off the current as soon as it got too hot. And people were starting to defeat the system by wrapping towels over their connectors. I think you probably heard about this a long time ago, but there was all that stuff, and then Tesla actually had to come out and tell people to stop doing that.
Yes, let's you can also fill your house with smoke if you put a wet towel over your smoke alarm. Isn't it great? No, the opposite. Question for you here. These high voltage cables coming in don't look like copper.
No, that's probably aluminum. And you can use aluminum. It's less conductive than copper, and that means that you will lose a little bit of efficiency there. But what you do get back is cost. Aluminum is way cheaper. And we do this too. We actually run aluminum in conduit if we can. And that just helps save cost, makes the station more affordable, which is good for the customer, good for the driver.
I had a chance to talk with a grid utility employee in Europe, and he said that they are trying to do aluminum sometimes, even for big installations, because it is just so much cheaper. I don't know if I can say anything more than that because it's all on background. So we don't know what this coil is over here. Maybe it's just slack so that if they're doing something, they've got some extra hose. I don't know.
Possibly. It seems like a lot so when you install, that's called a service loop. Is you kind of add a couple extra coils just so that you can use that slack for something. So you can have service loops for various things. That seems like an awful lot, and it seems quite structured for a typical service loop. So it's probably doing something else.
Now, yes. Oh, please. No, please.
On that board, there's another really important function that I was going to mention that the board does that I don't think a lot of people generally appreciate when they're charging their electric cars, but it's one of the most important things that a dispenser can do. And I'm not 100% certain, but it's probably on that board somewhere. And it's called insulation monitoring. And this is really, really key because if you have a short between some current carrying portion of the cable and ground, you are effectively one fault away from electrocuting something and possibly someone. And and insulation can break down, right? Like there's many different things that could cause insulation to break down. A rodent eating away at a cable, just the general wear and tear of something. So one of the most important things a dispenser does when it starts to make that connection is it runs this insulation monitoring device. And then that monitoring device is constantly monitoring if the current carrying cables are insulated from other aspects of the system, like ground, like the earth, in order to continue supplying current. And one of the causes of charging session failure is actually that insulation monitoring device tripping. And it can trip for a number of reasons, one of which is just plugging in the cable incorrectly. But that's super critical. It's a safety critical device. It's in every dispenser performing this function to keep people alive.
And that, remind me, is a good thing.
Yeah. Yes.
I hope so.
As a poor mortician, I'd say I like to I like to work with the living. So
Yeah. So that's true. This is a live. This is more of a vivisection than an autopsy. So a question I have always wondered is there are losses between the curb and the car.
Mhm.
They are heat. We know there's losses because there's heat. We can feel it. We can hear it. The first question is how much are they typically? And the second question would be what am I getting charged for? What the box used or what I got?
Yeah. Two really good questions.
Thank
I
you.
don't know off the top of my head what the V4s are capable of doing.
No.
Most systems are generally doing about 95% conversion efficiency from AC to DC. And I believe in most cases that also includes the cable. And then there are potentially other losses inside the vehicle as well, but those should be pretty minimal, especially for DC fast charging. And so that's pretty good, but you could imagine at 100 kilowatts, that's 5 kilowatts of heat, and we actually measure kind of heat generated in terms of kilowatts of it's equivalent to just power. So when we design cooling systems, we actually think about what is the total amount of heat rejection that they need to perform, and we actually say we want to target 5 kilowatts of heat rejection or something like that. Not all the heat is generated in the same place, right? So if you have a power cabinet and the power conversion is occurring, in a separate location, then some of the heat being generated is actually happening not in this dispenser, but 25 feet away in a giant cabinet where you have access to more airflow, things like that you can use to help dissipate some of that heat. So generally speaking, a decent fraction, and it can really depend on the system of the heat is being generated by power conversion. So in this case, the dispenser doesn't have to deal with all of the heat that is being generated in the system. It just has to deal with the heat being generated by the components here inside this box, as well as the heat being generated by the cable, as it plumbs all of that current through to the vehicle. And so that's what that big bulky cooling system is there to do.
And then the second question, how am I getting billed?
Good news, you are not being stiffed by the EV charging companies. They are measuring DC power and charging you for DC power, and they're eating it for the conversion losses.
Pricing it in on the
regulated. This is regulated, just in the same way that gas pumps are regulated. Actually, there's a whole standards body around weights and measures that makes sure that that EV chargers actually dispense what they say they are dispensing, and that you as a driver are actually charged what you are being dispensed.
Okay, so any efficiency that you pick up inside the cabinet, inside the stall itself, is money in your pocket or your client's or the station owner's pockets.
And that's important because it helps drive the technology forward, right? It doesn't just blindly pass on inefficiencies to the driver community.
And have you seen early charging companies building inefficient cabinets that were just, you look at it and you say, what are you doing? You're losing so much on the back.
It has never, I think the good news is that, everybody knew that this was going to be a problem. So we didn't start off in a very bad spot to begin with. I think historically, at least throughout my history working in this industry, it's always been 93 to 96% across the board. So it's always been pretty good. And it is slowly creeping up, but it is not necessarily, there's no dramatic shifts when it comes to energy efficiency. There are some ways where you can make things a little bit better by manipulating when you choose to convert AC to DC power. there's architectures like DC microgrids that will improve the overall conversion efficiency, but it's nothing dramatic, I guess.
When you're already at 93 to 96, you're kind of running out of headroom.
It
You
adds
can't
up over
exceed
time.
100. Yeah. Oh, absolutely. Absolutely. But it's not critical. It's not like we're an internal combustion getting 14 to
Right.
18% conversion with the rest just bleeding heat out into the world. Is this PCB board going to get smaller over time, do you think?
I mean, it could. If they wanted to make their
Is it important?
dispensers slimmer and smaller, they could. It doesn't seem like it's that important. I think over time, my guess is that what they really want to optimize is the cooling system and trying to package that into a smaller and smaller volume to make the dispenser, smaller.
And the last thing I wanted to ask is just looking at this, scale of 1 to 10 on the V4, what do you think of the engineering just in terms of layout?
Pretty good. It's always cool to see tight packaging, but tight mechanical packaging. It is. A lot of mechanical engineers they're like the best Tetris players you've ever seen, right? And I mean, we've got some good ones here. It's always really cool to see how they start to package things in really, really tight spaces. But I find what Tesla has done in the V4 dispenser to be quite compelling, and quite impressive generally. What's interesting is that there are other factors that are not always obvious. For example, like bringing those cables up through the conduit into the charger, is that's actually a thing that is quite, it has as it can be kind of problematic. Actually, a lot of people that install chargers complain if they have to bend the cable, because that cable does not bend, not very easily. And so if you notice those slight bends there as the cable has to kind of like work around the cooling system, those are things that, in general, people want to try to avoid when they're designing.
They have avoided it.
I think it's close, but it doesn't look like they've like quite hit it here. So they'll probably optimize that as time goes on.
Now, the exciting thing, we should tease this, is that we will be sharing some images of the insides of electric air cabinets, maybe even some CAD designs, but not today. We've got to get comments from you guys saying if you even want to see them. We've got some engineers in the audience who would love that.
Yeah, we'll definitely, as things kind of progress, we'll definitely be kind of showing off some of the stuff, some of the insides.
Maybe even by the end of this year.
Maybe, we'll see.
That is a good timeline. I will check my calendar. I have nothing scheduled that day, so that's going to work for me.
I'll hit you up New Year's Eve. No.
Oh, I was available, but you didn't respond in time. What? Come on. Guys, what did we miss? What did we misunderstand? What questions do you have about what we just looked at? The anatomy of a V4 Tesla charger from the inside. Oh, so spooky. Everybody else, like, subscribe, do what you do. Stay tuned to Juicy. And, I really do appreciate all you guys being here. And I cannot wait to hear from you clever robots when I bring Sith back to have another discussion about some other charging companies about which he can, again, only speculate.